Okay, so here we have Proposition 48, Book 1 of Elements. It says that if you have a triangle with AC squared, so the AC here is the distance between A and C, and if you have this length squared plus BC, the distance between B and C, this length, squared, equal to the distance between A and B squared, the third side, squared, then you know for sure that this triangle is a right triangle. Now, typically we could say this as if we call AC, we could, call this little lowercase b, and then we could call BC A, and then the opposite side to point C, lowercase c, and we could say that this is A squared plus B squared equals C squared. So if you have the side lengths in that relationship, then you know it's a right triangle. Now, to prove this, we're going to say that we can draw okay, CD perpendicular to BC with it exactly being the case that AC equals CD. So what does this mean? We can say we can take this point and we can draw a line that's perpendicular to BC, and we can call this point D, where we have this length is exactly the same as this length, and we can always do that. Now what we do is we complete this triangle, draw segment BD, and see that triangle, right? Once I draw BD, right? So once I draw this segment BD, then I should see that triangle, and I want to state it in the exact same way that I have A, B, C, so it's D, B, C, okay, is a right triangle. And then being that this is a right triangle, right, what do we know? We know that we can then apply Pythagorean theorem or Proposition 47, right? So this is Proposition 48. We could apply Proposition 47, which is just Pythagorean theorem, which says that in right-angled triangles, we have this side squared plus this side squared equals this side squared. So again, we see that DBC is a right triangle. So by Pythagorean theorem or Proposition 47, so by Pythagorean theorem, we have, I'm going to say CD squared plus BC squared is equal to BD squared. Now, I'm going to say by substitution, right, I have AC is equal to CD, and then CD is right here. I'm going to write this, and I'm going to say, instead of CD, I'm going to put AC. So I have AC squared plus BC squared is equal to BD squared. And what we can see now is that this here, right, we have also by given, what's given to us in this situation is that, AC squared plus BC squared is equal to AB squared. So I'm just going to write that, and I'm just going to compare these two. So AC squared plus BC squared is equal to AB squared. So by substitution again, we can say, if I call this whole thing, whatever, star, then this is also star over here, right? Because these two things are the same. This is AC squared plus BC squared. This is AC squared plus BC squared. This forces BD squared equal to AB squared. And we could say by substitution, or things equal to the same thing are equal, right? So things equal to the same thing are equal, right? And I can say, or by substitution, whatever one you want to use. I could say BD squared must equal AB squared. And then this, since BD and AB must be positive, this forces BD to equaling AB. And now, if we're careful, we should see that we got BD is equal to AB, right? So this is the same as this, right? We got BC congruent to itself, and then we have AC, the same thing as CD. So then I can say, so let's write this. So I got AC is the same thing as CD, that's good. Then I got BD is the same thing as AB, and then I'm going to just say one last thing. I'm going to say BC is the same as itself. So then I'm going to say by side, 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 triangle ABC is congruent to triangle DBC. And then now, to finish this off, well, triangle DBC is a right triangle. So, triangle ABC is a right triangle. And then you're done.